Hi everyone! So before we get started on talking about eigenvalues and eigenfunctions, we're going to do one more example like this where we just have like an ODE that we can solve. This one has a forcing function and we have two initial conditions and we're used to solve the BVP. So let's start by first finding y of c, finding our complementary solution y of c. We write our characteristic equation. R squared plus 4 is equal to 0, so R is equal to plus or minus 2i. Now that we have this, we can write our complementary solution. So y of c is going to be equal to c1 cosine of 2t plus c2 sine of 2t. We have our complementary solution. And what about our particular solution? I think that undetermined coefficients would be the best way because we have a simple cosine of x on the other side. So using the method of undetermined coefficients, we're going to try the particular solution to be a cosine of x plus b sine of x by the method of undetermined coefficients. So if we take the derivative of that, y of p prime, we're going to have negative a cosine of x plus b, negative a sine of x plus b cosine of x, and if we take the derivative again, we're going to have negative a cosine of x minus b sine of x. Alright, so this is what we get for y double prime of p. And if we plug it into our ODE, so substituting in our ODE, we are going to get negative a cosine of x minus b sine of x plus 4 times a cosine of x plus 4b sine of x. That is going to be equal to cosine of x. So kind of messy here, my handwriting is kind of bad, but let's rewrite it. We have this expression here, we're just going to equal our coefficients. So our cosine of x terms, we have negative a plus 4a, negative a plus 4a, that is equal to 1. Is that correct? I think so. And then our sine terms, sine of x terms, we have negative b plus 4b is equal to 0. So here we have b is equal to 0 and 3a is equal to 1, so a is equal to 1/3. Alright, so if b is equal to 0, this term is going to vanish and a is going to be 1/3. So I'm going to erase what I previously wrote, so just we could write our particular solution and then finally our general solution. So erasing this, I hope there was enough time for everyone to write down. So erasing this, we're going to have our particular solution is going to be 1/3 times the cosine of x. Alright? And our general solution, general solution is going to be y is equal to the complementary solution plus the particular solution. So our general solution is going to be our complementary solution, which is C1 cosine of 2t plus C2 sine of 2t plus our particular solution, which is 1/3 of cosine of x. Alright, so here's our particular solution. Now we can go ahead and use our initial conditions to solve our boundary value problem. And I'm going to erase this part of the board here so that I can have space. But here is what we need to know. Here's what we're going to use, which is our general solution. So I can erase this part right here. That is our general solution. Let's start with our left boundary condition, y of 0 is equal to 0. If we plug it into our general solution, we're going to get that y of 0 is equal to C1 cosine of 0 plus C2 sine of 0 plus 1/3 cosine of 0 is equal to 0. Sine of 0 is equal to 0, so this term vanishes. Cosine of 0 is equal to 1, and this is also 1. So we know that C1 is equal to negative 1/3. What about our right boundary condition? Our right boundary condition, we have that y of pi is equal to 0. So y of pi is equal to C1, which is negative 1/3, times the cosine of 2 pi, plus C2 times the sine of 2 pi, plus 1/3 times the cosine of pi. That is equal to 0. So the cosine of 2 pi is equal to 1, and the cosine of pi, that is negative 1. This term right here vanishes because of sine of 2 pi is equal to 0. So we have minus 1/3. This is also negative, so this negative 1/3, that is equal to 0. So negative 2/3 is equal to 0. So this tells us that there are no solutions. So therefore, this boundary value problem has no solutions. This boundary value problem has no solutions. And in a linear boundary value problem, it could either have no solutions, a trivial solution, a unique solution, or infinitely many solutions. So in this case, it doesn't have any solutions, but just in nonlinear boundary value problems, can we find like specific solutions, like 25 solutions, like 30 solutions? Like in linear boundary value problems, it's either one solution, no solutions, or infinitely many. In this case, this BVP doesn't have a solution. Alright guys, so next time we're going to be talking about trivial solution, eigenvalues, and eigenfunctions. I'll see you next time.